All right, so now that we got that done, we're going to move on to number 5. And it says, which of the following are monomials? And to circle them, well, monomials, let's break down that word. The first 4 letters are mono, meaning one. And what this means is basically one-termed expression. So we're finding expressions that are one term. And terms are anything separated by addition or subtraction. So basically, we're looking for anything and everything that doesn't have adding or subtracting in it. Okay, so number 5, is there any adding or subtracting? No. Negative 9s squared is one term. That's a monomial. The number 8 doesn't have any adding or subtracting in it. It is indeed a monomial. Number 7, there's adding, there's subtracting. This is a polynomial expression. This is not a monomial, so no good. And number 8, 9DGH, if you're all multiplying, it doesn't matter if there's parentheses, if there's not. There's no adding or subtracting. You are indeed classified as a monomial. Perfect. That was quick. Now let's go on to the simplifying ones. Leaving no negative exponents if necessary. Leaving no negative exponents. So the first one, we're going to need to divide negative 24x squared yx all over 36x y to the third z. We're going to reduce this using our quotient rule. Quotient rule says you reduce the numbers like you normally would and subtract the exponents of any like bases. Let's make this a little more bigger. So I'm going to reduce negative 24 over 36, reducing by a factor of 12. You're going to reduce it as a factor of 12, and that's negative 2 over 3. And the x's, we're going to, first of all, I see an x on the bottom and an x to the first on the top. Those can cancel out. You can just cross those out, play Fruit Ninja, as we say in class. And we're just going to have nothing left but x squared on the top. And the y to the third and a y to the first, we're going to subtract the exponents of any like bases. 3 minus 1 is 2. And the extra 2 y's will be left on the bottom. And z doesn't have anything to cancel out with. If you don't use it, you don't lose it, as Ms. Spainhower says. On the next one, another quotient rule problem. We have negative 15 over negative 35. A negative divided by a negative is a positive. Those negative signs are going to cancel each other out. Factor out a factor of 5, and you have 3 on top of a 7. The b's, you're going to have b to the 4th over b. That's going to be b to the 3rd on top. 4 minus 1 is 3. And the a's, 2 minus 1 on the bottom is a to the 1st will be left on the bottom. Now, things that don't need to be put, a to the 1st, if you have an exponent of 1, you don't need to write exponents of 1. You don't need to have coefficients of 1 either. So you should have 3b to the 3rd over 7a. For those two. Number 11, this one's nice and quick. Anything and everything, doesn't matter what it is, to the 0 power is 1. Done. Anything divided by itself on number 12 is 1. On number 13, this is our first product rule 1. This is our first product rule 1. This is the rule that says you multiply any coefficients, any normal looking numbers in front of your monomials. You multiply those like you normally would. Negative 7 times negative 2 is 14 times 3 is 42. Now, what do we do with the exponents on any variables that we see? Well, when in doubt, stretch it out. If we needed to, we could stretch out. This would be 2 x's, and this would be another x over there. If I had stretched it all out, that would be x, and another x. That would be x to the 3rd power. So the trick is, or the rule is, for the product rules, is that we add the exponents of like bases. And the a is a to the 1st, a to the 5th. That is going to become a to the 6th. And y times y is y squared. Another product rule 1 on number 14 is 7 times negative 2 is negative 14. N to the 3rd times n is n to the 4th. P to the 5th times p to the 3rd. Add the exponents. P to the 8th.